And welcome back to another episode of the Game Engine Series. So I'll keep this intro shorter than last time. I know it kind of got a little long, but what are we doing today? Cameras. So we're gonna, more specifically 3D cameras. So we're gonna do quite a bit. We're gonna build more of a base camera class or struct, and then we're gonna implement the editor camera, which is gonna be the camera we use for the rest of the series as our engine editor. So that's kind of again, that first app we're building, first game, is our game engine editor. So that's where all the UI will be. So that's gonna be the camera we use in there. And then to do that, we will also look at view projection matrices. Not gonna get into details about the math. There's lots of great resources out there. I think I mentioned in the code, but OpenGL book, like lots of YouTube videos are out there. Like the Cherno is a good camera video. So yeah. So if you want to get into the more nitty gritty stuff, go check out other resources. But I, again, want to keep the series moving forward and just keep progressing and making cool things. So yeah, that's kind of all I have, but let's get into the camera code. Okay, and welcome back. So just to kick things off and get right into it, what we are going to need to do is grab the latest version of Zimp, and you want to make sure it's overwriting existing. That's what we want. We want it to update because we're going to use .obj files today, and the latest version includes that. So both of these should be updated. If you look, they'll get updated. So yeah, so let's get right into it. So let's see. So math is going to have some changes. There are some things I'm going to do. Like we're going to use Quaternions, but ZLM doesn't support Quaternions. So I know people may not want this, but I am just going to copy and paste the code in. People may not want this, but I don't want to get into teaching Quaternions. I want to get into the camera. But for that, we need the implementation. Okay, so we'll just come in here and do that. So we look here. So these kind of got updated. This is now called ZLM instead of math, just so it's more explicit because now we have other math stuff. So we have our Quaternion, which we need an identity. And then there's just a bunch of functions that will operate on it, standard to Quaternions, and there'll all be ones we need. And then there's some tests in here. So if we just quickly run Zig build test, we'll see all our tests pass, and that's exactly what we want. So now let's actually get into the interesting stuff of adding a camera. So there's going to be two things we do. So we're going to add camera.zig and EditorCamera.zig. So camera.zig is basically going to be our root, and then EditorCamera will be the editor camera. So it'll handle things like input, and so we can pan around the screen, and it'll act when we actually go and write our editor, which that's kind of what our first game is. That's exactly what we want. So we can go C const math equals at import. All this code I will write from here on out, except for adding tests. If there's any tests, then I will probably just paste those in. But let's go core event.zig, and we will need z event. Nice. So then let's also just make things a little easier on us with get vec3, mat4, and Quaternions. Okay, so now let's define our camera 3D because we are making 3D game engine at this point. So that is kind of what we need. Orientation, that'll be our Quaternion. So Quaternions basically are just a more complex rotation. So that's like, it'll orient us in space. And yeah, I don't want to get into the implementation of them, but just wanted to give a brief summary. And then yaw and pitch. So these are going to be our Euler angles. And this will be our projection information. So we'll have some constant max pitch 32 math.pi, and then just a little bit of tolerance, and then the world up, which will just be something that'll help us for now. We could always make this be passed into a init, but for now we won't. So pub function init, so this will take a position and an aspect ratio f32, and then it will turn the camera 3D. So var camera It's Camera3D. So obviously position will be position. Dot orientation will start at Quaternion at the identity. Field of view. Math.pi. So that's 45 degrees, I believe. Aspect equals aspect. And again, something like FOV, we could make this a parameter. It's totally up to you. For now, we're just going to keep it hard-coded, but we need to change it. Any of these could be passed in as parameters, and we can always update that in the future. Equals 0, and then we'll call a function. That's why we made that a var, and then return it. So we haven't written that function yet, obviously, but we'll do that right now. So orientation, self, Camera3D, and then the yaw and pitch from the Quaternion, from axis angle, a new 0, 1, 0, self.yaw. This will be pretty similar, except instead of yaw, it'll be pitch. It'll be 1, 0, 0, and self.pitch. And then self.orientation equals yaw.multiply pitch. So those are all Quaternions, and then just orienting us in space. So now we're just going to write essentially a bunch of helper functions. So a function to get like data we may need from the camera at any time, like the front. Camera3D, vec3, return self, orientation dot rotate vec3, vec3 dot new 0, 0, -1. And this one will be similar, but it'll be right. And this one will be 1, 0, 0. And we also need up, which will be 0, 1, 0. Nice. Now that we have that, we can get kind of a combination of different things. So let's do view matrix, Camera3D, and a mat4. And I do highly encourage people to go look at, I didn't even say the OpenGL book is a great intro to this. Self.position about how cameras work and what view projection matrices are, because we're going to be using them today. Yeah, so if you don't have any idea, I highly recommend you go check out the OpenGL book, because it will make a lot of this just make more sense. But what view matrices are, view projection, all those kinds of things. And there's also lots of resources like on YouTube and stuff. I know Cherno has some videos when he gets into cameras. So if you are confused, please go check other things out. And I'm not trying to make this an all-inclusive tutorial where it's spending a lot of time teaching and then we're not actually implementing as much. I really want to focus the series on actually implementing things. So that's why I feel like a lot, in my opinion, a lot of things like this kind of lack, how I find it over teaches and then it doesn't actually get to very complex things. But if you're like me and you want to see the complex things, this is exactly what I'm trying to do for you. Camera3D, return a mat4, return self.projection matrix, multiply with self.view matrix. Then the last function here will be process event. So this is how we can write our editor camera to actually handle input events. Event void. Then we switch on the event. Or actually, I was wrong about that. The editor camera will take an input or use input and do its own thing to change how the camera is oriented. This is actually frame buffer. This is to resize the camera whenever we have a resize event that happens. So if resize.width is greater than 0, resize.height is greater than 0, we change the aspect ratio because now we have to maintain it at float from int resize.width divided at, so need that be an F32 at float from int resize.height. And then just else do nothing. There we go. So that's great. So now I'm just going to add some tests. This definitely isn't very comprehensive, but there are just a few tests here. And I very much encourage people to write more. So if we just build and run. Oh, that one actually isn't going to do anything yet. And neither will the Quaternion test. So if you got that, good on you. Let's do this quat at the quat. We'll also want up here 3D import scene camera 3D. It's actually move this down here. But now if we get over here, we do want scene camera underscore equals core/map. So now I believe they should run. There we go. See, we're up to 35. So that means it was 31 before. So now these are running. Okay, so now we're over at EditorCamera, and let's start with our imports as always. Standard library. Obviously need math. Core math. We will want input. Core input. Input manager. 3D equals camera 3D conc event add import core event c event. And then we also want vec3, just makes it a little easier to work with as always. Now we can define our editor camera. We also could optionally define this inside of editor code because technically this will be our editor and we'll probably move it over at some point because if you think about it, like every single game should need an editor camera. Anything that goes in runtime really should just be things that is at the core of every single game that any game engine kind of implements for you. So this probably should exist inside of editor at some point. But for now, I'm just going to keep it in here to keep things simple. But if you want to have it defined somewhere in here, by all means, go for it. So our editor camera will have a camera itself, and now we'll have things like look, sensitivity, which maybe our editor will be able to control these fields one day, and some sort of settings that may exist. Zoom speed, and then we will init. Position will be a vec3, and just like the camera, we want it to be taking the same params. So camera equals camera3D .NET position aspect, not address space, aspect, and then look sensitivity. We'll just hardcode these for now. Again, this maybe in the future, the editor will be able to change this itself in some sort of settings, but I just found these numbers work for me for right now, and this is where you'll change it if you find things are either too sensitive or not sensitive enough. And we go and use it. So now we will update editor camera void const delta equals input dot get mouse move delta. So if input dot is button held dot right self dot camera dot yaw minus equals delta dot x times self dot look sensitivity. Then we'll do the same thing with pitch, but with y. Now it's self dot camera dot pitch equals sd math clamp self camera dot pitch minus camera 3D dot max pitch and camera 3D dot max pitch. and then self.camera.update orientation. So that's kind of our looking around. If that makes sense. So next will be more panning, or no, sorry, right is panning. So this is kind of a simple implementation of panning around when you hold right click. And now if we do input.is button held dot left, this will be like actually moving, emulating like you're moving around. So you'll kind of click and drag and be able to move around. Dot camera dot right const u equals self dot camera dot up. So in self dot camera dot position, self dot camera dot position dot sub r dot scale delta dot x times self dot pan sensitivity. Going to be a very similar thing. So then we're adding on x. We can also add on y. That'll be a little bit easier to read. Trying to keep the screen as big as possible. Instead of r, it'll be u. So brighten up by x and y. I think that hopefully makes sense. And then the last one will be scroll. But get mouse move scroll. If scroll.y is not equals 0, self.camera.position equals self.camera.position.add self.camera.front.scale scroll.y times self.zoom speed. So again, if we're scrolling either forward or back, we will scale by that value zoom speed at like that as fast as zoom speed. Last function to add is process event, which is just a pass through. EditorCamera event, C event. Self.camera process event. Nice, so let's head back over to root. And it's probably a good thing to do is add it here, even though we don't have any tests. It always could be added in the future, and I encourage you to write tests. Again, I'm not gonna write it all on camera. I may add it off screen or something, but yeah. So now let's do editor camera, and you'll see it all here. So that should be everything we need. Let's just make sure there was no compiler. So all our tests pass and check builds. So that means we can head over to our game scene. So if I just run what we had last time. So again, remember we updated Zimp, so it'll take a while to rerun. That's expected on the first time. I'll just cut to when it's done. There we go. And again, as before, we have our single triangle that we can move around. And we can see, I also implemented caching in the latest version of Zimp. So see it cook this every time, but if we were to rerun, we can see it's cached, so it's not going to recook. And you see the kind of speed up there, which will be a lot more noticeable with the next asset we add. So I'm actually going to start by adding that asset. So we go to assets, meshes. I'm going to call it monkey.obj. So make sure it's .obj or else it won't get picked up. So what I've just done is I copied in the object data for Suzanne, the famous monkey. It'll be on the GitHub as always. So yeah, you'll be able to find it there, be able to copy it and paste it in. So yep, it'll be right there. And if we just build, we can see it cooked it in a millisecond. And now if we rerun, now you can see it 1 millisecond down to 24. So that's good. So we have our asset there. And then we can also double check that. We see we have triangle.cmesh. So that's pretty awesome. So now let's hook things up. So one thing we do is we actually don't even need vertex ray in there anymore. But what we can do is add editor camera equals editor camera, and we do LSP restart. Take a second. And there we go. So we no longer will need the vec3 or vec2, but we will want vec3 now. So instead of offset, we will now hold editor camera, which will be an editor camera. So again, don't need offset, but instead self dot editor camera equals editor camera.init vec3.new. Started about 3 spots away. You can play around with that number, whatever looks good to you, and we'll do 16:9 aspect ratio. So now the next thing we're going to do is we're no longer going to be rendering the triangle, but we'll be going for monkey. And then because we're now rendering 3D, we'll have to do enable GL depth, which again, this will be abstracted into our renderer when we build our renderer, but for now it's not there. And then on update, we actually no longer need all this. And we actually aren't going to be using delta time for now, but we will be able to do self.editorCamera.update at the start of every update. So if you remember, this is just, it needs to be able to check the input itself. And now another thing we have to, because we're doing depth now, it's 3D depth buffer bit also need to be cleared. And we will be making some changes to our shader. So obviously we're not using offset anymore. Instead, we're using view and projection. Oops. Where'd it go? So self.editorCamera.camera.viewMatrix. And then we will also be doing projection. And then we'll get the projection matrix. So we can pre-compute this if we wanted. That we will eventually optimize for that, but I'm just trying to be explicit of exactly what's happening. And now on event will be self.editorCamera.processEvent. And I believe that's all the changes we need there. Now we just need to go over to our vertex shader. So we'll keep that. So again, we don't have U offset anymore, but we have view and projection as we just added. And now GL position be a little different. So it's still going to be a position, but projection times view times that. So hopefully projection, I did spell that all the same, and view is the same spelled. So moment of truth, if we made a mistake or not. Okay, so it's somewhat there. It's definitely not, something's wrong somewhere. We cannot see, yeah, something's definitely wrong somewhere. Let's try and find where that's at. Okay, I think I figured it out. If we go back to game scene, it's because this should be depth test and not depth. So let's try and run that again. There we go. That is exactly what we want. So now this is me using my mouse wheel. This is me using left click. This is me using right click. Kind of looks a little stuttery, but might just be my mouse. But yeah, so now we kind of truly have a real editor. We can go around, look at things, zoom in, zoom out, and we're also rendering a 3D object. Like that is really cool. And if like you made it this far, you're following along, like great job. Like this is not easy to do. This is a really cool thing. And yeah, that's kind of all I had for this episode. So I hope you guys enjoyed. And that was the video. So I hope you guys enjoyed. I hope you learned something. I hope if you're following along, you're making lots of progress. And yeah, I mean, I think it's pretty cool. We rendered a 3D object to the screen. That's pretty cool. We can look around. We can move in a world space now, which all very cool things. So yeah, if you enjoyed, like, comment, subscribe, all those things really help the channel. And if you want to come chat, the Discord link's down in the description. But yeah, I am trying to keep these intros and outros short. So hope you have a great day.